ሰላም የቻናላችን ተከታታዮች እንደምን አላችሁ? የ10ኛ ክፍል ፊዚክስ አዲሱ ካሪክለምን ዩኒት 1 ቬክተር ኳንቲቲስ በሚለው ዩኒት ውስጥ 1.2 ቬክተር ሪፕሬዘንቴሽንስ የሚለውን ሴክሽን ይዘንላችሁ ቀርበናል። እንደተለመደው ለቻናላችን አዲስ የሆናችሁ ሰብስክራይብ እንድታደርጉ እየጋበዝናችሁ በተጨማሪም ይህ ቪዲዮ ለብዙ ተማሪዎች ይደርስ ዘንድ ላይክ ኤንድ ሼር ማድረግን እንዳትረሱ እያልናችሁ የዛሬውን ትምህርታችንን እንጀምራለን ማለት ነው። 1.2 ቬክተር representations. How can you represent a vector? Vector quantities are represented either algebraically or geometrically. So you can represent a vector in two ways. The first one is algebraically, the second one is geometrically. How can you represent a vector algebraically? Algebraically, a vector can be represented by a bold letter as A. Here, the bold capital letter A represents a vector. This bold capital letter A represents a vector. Another way of representing a vector is an arrow over the letter. For example, writing the letter A and putting an arrow over it, it represents a vector again. This is another way of representing a vector. So, letter A, by writing a letter A and putting at the top an arrow, it represents a vector. Let's see an example. A displacement can be represented by the expression S equal to 50 kilometer southwest. Here S equal to 50 kilometer represents the magnitude of the vector, but southwest represents the direction. Southwest represents the direction. So S equal to 50 kilometer describes only the magnitude of the vector, and the southwest describes the direction of the vector. Here, the magnitude is also indicated by placing the absolute value notation around the symbol that denote the vector. So you can write equivalently S equivalent to absolute value of S. So when I write within an absolute value, S, it represents magnitude. So when I write 50 kilometer, it describes the magnitude. Absolute value equal to 50 kilometer, it represents a magnitude only. But if you want to describe within a direction, you must mention the direction south, west, or southeast. So in short, vector quantities can be represented algebraically and geometrically. Algebraically, you can represent it using a bold letter or an arrow over the letter. The best example is here displacement S equal to 50 kilometer southwest. This represents a vector called displacement. So S equal to 50 kilometer describes the magnitude of the vector, and the southwest describes the direction. The magnitude of a vector or a magnitude of the quantity can be represented using absolute value notation. Okay, using absolute value notation. So if I write S within an absolute value, it represents the magnitude. The magnitude is 50 kilometer. The magnitude is 50 kilometer. But the southwest is the direction. The direction. This is the direction. The direction. So a vector quantity, as you know, vector quantity is described using magnitude and direction. So don't forget to mention these two things when you are representing the vector physical quantity, which is the magnitude and the direction. Another ways of representing a vector is geometrically. How geometrically represent a vector? To represent a vector geometrically, you can use an arrow or an arrow tipped line segment, or you can use an arrow tipped line segment, which is like this. Let's see an example. Here is a line. If the line, this line, if there is an arrow tipped, if it is an arrow tipped, this we call it, this line is an arrow tipped line segment. This represents a vector geometrically. Here it has the first point, the initial point. This is the initial point, which is called tail of the vector. The initial point is the tail, and there is a final point. That final point is the head. The head is the final point. The distance or the length between the tail to the head represents the magnitude, and the head represents the direction of the vector. While you are representing a vector geometrically, you must specify the length and the direction. The initial point of the arrow is called, as I told you, you can call it the tail, and the final point of the arrow is called the head. The head represents the direction. The length between from the tail to the head, from the tail to the head represents the magnitude of the vector. Let's see an example. Figure 1.1. Figure 1.1 shows head and tail of a vector. Here is the tail, the initial point. Here is the head, the final point. The length from the total length from the head to, from the total length from the tail to the head is the magnitude, and the arrow represents the direction. So the length of the arrow represents the vector magnitude, and it must be drawn again in a scale if it is drawn in a scale. Okay, so the length of the arrow represents the vector magnitude, and the length must be drawn in a scale. The second point is the arrowhead. The arrowhead represents the vector direction. So here, as you see in the figure 1.1, it shows you the head and the tail of a vector, which is represented geometrically. Let's consider some notes, some consideration. When you decide to represent a vector geometrically, you must draw your drawing using a scale. For example, if you want to represent a 2 Newton vector on a piece of paper, you need a scale. You must decide your scale. So you might consider, or you might let 1 centimeter on a paper represents 2 Newton. So 1 centimeter represents 2 Newton. This is a scale. The other example is a force of 20 Newton, toward the east direction. It would be represented as an arrow of 10 centimeter long. An arrow of 10 centimeter long on a piece of paper may represent a 20 Newton toward the east. An arrow of 1 centimeter on a piece of paper may represent a 2 Newton. In this fashion, you can represent a vector on a paper, or you can represent a vector geometrically. When you draw a vector, but always you must not forget the scale. Here, why we need a scale? A scale allows us to translate the length of the arrow into the vector's magnitude. Why we need a scale is it allows us to translate the length of the arrow into vector's magnitude. Here, the most important thing is to choose the scale that produce a diagram of a reasonable size. You must consider these things. When you choose a scale, that scale must produce a reasonable size. The other point that you must consider when you represent a vector geometrically, you must consider the reference direction. This reference direction, it may be a line that represents the horizontal surface, or it may be the point of the compasses. Okay, the point of the compasses. The point of the compass, when you say to the north direction, to the south direction, east to west, or you can consider the horizontal surfaces as a reference direction when representing a vector geometrically. Generally, when you represent a vector graphically or geometrically, you must consider the following four procedures. The first one is decide upon a scale and write it down. You must decide your scale and you must write it down. The second one is determine the length of the arrow representing the vector by using a scale. The third one is draw the vector as an arrow. Here you make sure that you fill in the arrowhead. The fourth one is fill in the magnitude of the vector. So don't forget these 4 points while you are representing a vector graphically. The first one is you must decide the scale. The second one is you must determine the length of the arrow, which is representing the vector. The third one is you must draw the vector as an arrow, and the fourth one is you must fill the magnitude of the vector. Let's see an example. To make it clear, the geometrical representations of a vector, let's see an example. Here, draw the vector 16 kilometers to east to scale by indicating the scale that you have used. Here ምንድነው 16 ኪሎ ሜትር to the east የሚያሳየውን ቬክተር ድሮ አድርጉ ነው። ስኬላችሁንም ዲተርማይን አድርጉ ነው የሚለው። ይህን ለመስራት the first step is to solve this problem. The first step is you must decide a scale. So let us decide our scale. So let 1 centimeter represents 4 kilometers. So if 1 centimeter represents 4 kilometers, if 1 centimeter represents 4 kilometers, how many centimeter will represent 16 kilometers? So from here the 16 kilometer can be represented by 4 centimeters. So 4 centimeters. So if we draw a 4 centimeter length arrow, it can represent actually a 16 kilometer. So by using this information, our direction is to the east. So first we must put our reference direction. This reference direction is, this is the horizontal line, this is a horizontal line, this is our reference. So having this horizontal line, so it's possible to draw our vector which is 16 kilometers to the east. This horizontal line, this direction is to the east. If you consider the compass line, this horizontal line indicates the east direction. So we can draw a parallel line of 4 centimeter, a parallel line of 4 centimeter for the horizontal line from our reference direction. This horizontal line is our reference direction, so we can draw a 4 centimeter. This 4 centimeter arrow represents actually 16 kilometers. This is how you are going to determine a scale and how you are going to represent a vector graphically. The first point is decide your scale. Here, in our case, 1 centimeter represents 4 kilometers. So if 1 centimeter represents 4 kilometers, so how many centimeters will represent the 16 kilometers? So the 16 kilometers can be represented using 4 centimeters. The second step is draw your arrow, the vector arrow. So while drawing, you must have a reference point. Our reference point is the horizontal line or the east direction. So drawing a line of 4 centimeters, which is parallel to the horizontal line, represents the 16 kilometers to the east. So here figure 1-2, a scaled diagram for a vector with a magnitude of 16 kilometer. The next point that we are going to see is types of vectors. In this section, we are going to see 4 types of vectors. The first vector is called zero vector or null vector. What does it mean, zero vector or null vector? A vector with zero magnitude. A vector with zero magnitude and no direction is called zero vector or null vector. The second type of vector is unit vector. A unit vector has a magnitude equal to 1. If a vector has a magnitude equal to 1, this vector is said to be unit vector. A direction of a unit vector can be any direction, but the magnitude is always 1. The third types of vectors are equal vectors. These vectors have the same magnitude and the same direction. When 2 vectors have the same magnitude and direction, these vectors is called equal vectors. Here figure 1.3 shows 2 equal vectors. Let's consider this vector A. This is vector A and this is vector B. Vector A and vector B are equal vectors because they have the same magnitude and the same direction. The fourth vector is called negative of a vector. What does it mean, negative of a vector? A vector that have the same magnitude but opposite direction within the given vector is called negative vector. When 2 vectors have the same magnitude but opposite direction, it's called, these vectors are negative of a vector. If I draw a vector which is parallel to a vector A and B, or if I draw a vector which is parallel to B, but if the direction is opposite, these 2 vectors will be negative of a vector. So negative of a vector in terms of magnitude they are the same, but they do have opposite direction. ለዛሬ ይዘንላችሁ የቀረብነው ይህንን ይመስላል። በቀጣይ 1.3 ቬክተር አዲሽን ኤንድ ሰብስትራክሽን የሚለውን ሴክሽን ይዘንላችሁ እንቀርባለን። በዚህ ሴክሽን እስከምንገናኝ ድረስ መልካም ጊዜ ይሁንላችሁ። አሁንም በድጋሚ ይህ ቪዲዮ ለብዙ ተማሪዎች ይደርስ ዘንድ ለቻናላችን አዲስ የሆናችሁ ሰብስክራይብ እያደረጋችሁ የቻናላችንም ቤተሰብ ይሆናችሁ ላይክ ኤንድ ሼር ማድረግን እንዳትረሱ። እየተከታተላችሁን ስለሆነ እናመሰግናለን።